All right, so this is lesson 1.3, solving equations with variables on both sides. You've been doing this. We have to rearrange and simplify our equations so that you have your x or v or t, whatever the variable is, isolated on one side and every other number on the other side. We like left and right, but that's not necessarily required. So, example 1, we're going to write this in your journals. So everybody got your journal? Put EX1. All right, everybody write the equation. 15 minus 2x equals negative 7x. If we are trying to combine all the like terms, what would be the first thing I need to do, Logan?
Plus 7x on both sides.
You could, however, we're trying to get everything away, so I would probably move the 2x over here. So how would you move the 2x?
And do plus 2x.
Correct.
So negative 4.
So we're going to add 2x over here, which would make it negative 5x. Very good. Now, how do I isolate the x? How do I get the x all by itself? Get that negative 5 away from it, Melly? Yeah, we're going to divide by negative 5. Very good. So that cancels everything on the right, which leaves you with just the x. What is 15 divided by negative 5? Negative 3. And then the more proper way to write this is just to flip it over and say x equals negative 3. Make sense? What questions might you have? Good? I see some furrowed eyebrows. That just means I'm confused. All right. If you've got it, go ahead and go try it's 1 and 2. Does anybody need me to leave the example up longer so you finish writing it? Everybody got it? Excellent. All right, so we're going to solve the equations.
Yeah.
All right, so example 2. Yes, right? Yeah.
Yes,
example 2. Think how he's answering. It's not even his class. I appreciate that. All right, so our first step is what? Write the equation. Did you all write the equation?
Yes.
Excellent. What would be our next step, Logan?
Do distributive property.
Yes, distributive property. So what is negative 2 times x?
Negative 2x.
Negative 2 times negative 5.
That'll be 10 positive.
Positive 10. Very good. All right, on the other side, somebody else. What are we doing there? 6 times,
6 times 2. 12.
which would be 12, and then 6 times negative 0.5.
Negative 3x.
Very good. Oh, yeah, don't forget the x. All right, so now that we've simplified, now we can combine like terms, correct?
Yes.
So what do we want to move, the negative 2x or the negative 3x?
Negative 3x.
So we're going to do the opposite of negative or subtraction, and we're going to add. So 3 plus negative 2 gives you what? X. Very good. Now we're going to move the 10. How do I move the 10?
Minus 10 on both sides.
We're going to subtract 10. 12 minus 10? 2. X equals 2. Any questions? All right, you have 2 more try it's, 3 and 4. Did somebody say no? I don't know, but it was funny. Let's see if it works. There we go. All right, example 3. Write down 3 minus 4x equals negative 7 minus 4x. We need to combine like terms. What's our first step? Hold on, Logan. No, Julie, go ahead. Wild guess.
Add 4 on both sides.
We're going to add 4x to both sides. Excellent. Shh, whisper, you guys. So then I canceled out all my x's. So I have 3 equals negative 7. Can I have 3 equals negative 7?
No.
No. So that would be called no solution. because 3 can never equal negative 7. So then all you have to do is write on your paper, no solution.
Oh, so we just put no solution?
Yeah, you don't have to, I mean, you have to solve like we did, but you don't have to go any further. Just say no solution. So when you're doing it on the computer, it'll give you an option with it's one solution, no solution, or many solutions. All right, try it 5 and 6. So 2 more?
Yeah.
Yep. Work on those. All right, so this is example 4. Whisper. Example 4. What is our very first step? What is our very first step? Write the equation. Excellent. What's our next step? Julie.
You times 4 times 3 over 2.
Yep, distributive property. So 4 times 3 halves and also 4 times 1. What does that give you? 6x plus 4. What do you notice here? They're the same. We're going to keep solving it just so you see what happens. But when you already see it there, you already know the answer to this. But if we move the 6's to both sides, you come out with 4 equals 4. Does 4 equal 4?
Yes.
It does. So this is a true statement. But if you were listening to me teach algebra yesterday, this is telling you that I have one line and I drew another line on top of it. So then all the dots on the line are anywhere along here. So there is many solutions to this. What you can think about is if I plug a number here where this x is, and I plug a number here where this x is, the same number, like say I put a 2 there, this side is still going to equal this side. It's going to come out to be the same answer. So there are an infinite number of answers I could plug in here. I could put 2,727,000 right here where the x is, as long as I put the same thing here. Then this side is going to equal this side, right? Yes. So the answer to this, infinitely many solutions. For your work, you can just put many solutions because trying to spell infinite over and over again is lots of fun. So your answer is many solutions. Yep. One equation, many solutions. What questions do you have about this? Any? None? Good?
So when it gets to the point where it says, like 4 equals 4, that's when we just say many solutions.
Yep. As long as 4 truly equals 4. If I have 4 equals 72, then no. That would be no solution.